Whenever you log in, buy a product, or sign up through a newsletter, your browser is silently packaging your keystrokes and shipping them off to a database. The mechanism making that possible is the HTML form. It takes a static, read-only web page and turns it into an interactive bridge, allowing information to flow from the user directly to the server. To build one yourself, you only need two things: a basic understanding of standard HTML document structure and a simple text editor. We are going to look at 4 specific HTML tags. By the end of this, you will use those 4 tags to construct a fully functional user registration form from scratch. Putting these precise elements together is what allows a website visitor to step out of the audience and actively participate in the application. Every input field you create must live inside a master container. In HTML, this is the form tag. It is completely invisible on the page, but it tells the browser exactly which pieces of data belong together. To make the form work, we need to tell it where to send the data. We do this using the action attribute. It acts as the destination address, usually a specific file on the server, like register.html, waiting to process the user's input. Once the form knows where to go, it needs to know how to get there. The method attribute dictates the courier protocol for how the package data will actually travel over the network. The default method is called get. When you use get, the browser retrieves the form data and attaches it directly to the end of the web address, or URL. Because the data is right there in the address bar, it is highly visible to anyone looking at the screen, and browsers restrict the total amount of text you can send this way. If you are handling passwords or large blocks of text, you need the post method. Post embeds the user's data securely within the body of the HTTP request itself. This keeps the information hidden from the URL string and removes any restrictions on data length. Setting up the action and method attributes is your first step. It is a deliberate choice about how secure your data needs to be and how much of it your system can handle at once. With the container built, you can start adding fields. This table from our text shows the input element. It is a single HTML tag that changes its entire visual interface and function based on one attribute, the type. Setting the type to text creates a standard input box where a user can type a name or an email. Changing that exact same tag's type to password creates an identical box, but automatically converts the user's keystrokes into unreadable dots, masking the characters. When you need a user to make a mutually exclusive choice, like selecting a single item from a group, you use the radio type. If you want them to be able to make multiple selections at once, you use the checkbox type. There is a strict rule when setting up radio buttons. If you give each radio button a different name attribute, the browser treats them as separate questions, allowing both to be independently selected. To link them together so only one can be chosen, every radio button in that specific group must share the exact same name attribute. Finally, you need a way to execute the form. Setting an import type to submit creates the button that actually packages the data and fires it off to your action address. Setting it to reset creates a button that instantly clears all the user's entries, reverting the form back to its default state. Because one single tag handles 6 different interface elements, building a form doesn't require memorizing a massive dictionary of HTML tags. It just requires strict management of the attributes within the input tag itself. A standard text input is functional for a single word, but it becomes difficult to read if a user needs to write a long paragraph. Looking at this code snippet, the solution is the text area tag. Instead of a single line, you can define the exact height and width of the input box by setting the rows and calls attributes. Here, the box will display 4 rows of text and be 20 characters wide without scrolling. If you have a massive list of choices, like all 50 US states, a line of 50 radio buttons would take up the entire page. To save space, you use the Select tag to create a compact drop-down menu. The Select tag only creates the menu box itself. To populate that menu, you have to nest individual option tags inside of it to define the actual items the user can click on, like Ahmedabad, Rajkot, and Surat. Deploying text areas and drop-down menus allows you to collect highly detailed data without bloating the interface and overwhelming the user. Now we assemble all of this into a functional registration form. Looking at this source code, We establish the standard HTML document head and body tags. Then we open our master container, the form tag, assigning it the name FRM registration and setting its action to target a file called form.html. Inside the form, we deploy our shapeshifter elements. We use input tags with the type set to text box to create 3 separate fields for collecting the user's first, middle, and last name. Each input has a unique name attribute, so the server can tell them apart. Next, we collect the user's gender. We use 2 radio buttons that share the exact same name attribute, gender, so they work together as a single choice. Adding the checked attribute to the first option tells the browser to pre-select male as the default state when the page loads. We follow that with 3 checkboxes for hobbies, allowing the user to check as many as they want. Finally, we implement a text area spanning 5 rows and 70 columns to give the user plenty of room to type out their full physical address. That is your complete toolkit. Wrap it in a form container, use input tags for specific choices, deploy a text area for paragraphs, and select menus for long lists. Possessing this precise HTML architecture empowers you to build any data collection tool imaginable. Open up your text editor, organize these core tags, and start turning your static pages into interactive applications. Building a web page from scratch can feel like trying to untangle a massive knot of threads in the dark. Every single piece of structure has to be manually positioned and typed out. This image shows the raw HTML needed for a basic web form. Writing tags line by line is slow, and one missed bracket breaks the layout. But the goal is a clean, functional registration form, seen here in the browser. To bridge the gap between that complex code and the final design, we use an IDE. An IDE stands for Integrated Development Environment, a single application providing a complete graphical toolkit, a text editor, and a debugger, all in one place. The core operating principle behind this specific IDE is WYSIWYG, an acronym that stands for What You See is What You Get. Instead of typing out raw text and hoping it renders correctly, you place elements directly onto a visual canvas. The software writes the underlying code for you automatically in the background. When you first launch KompoZer, the immediate priority is to verify your workspace layout so that your design tools are actually visible. If any panels are missing, you can restore them by opening the View menu at the top, clicking on Show Hide, and checking the necessary toolbars. The primary command center is the menu bar across the top edge. Below it are the composition and format toolbars for file management and styling. On the left is the Site Manager pane for navigating files. The largest section is the central page area, your primary canvas for visual assembly. Taking a moment to identify and arrange these sections right at the start ensures you won't have to hunt for tools later in the middle of a project. Down in the bottom right corner is the Edit Mode toolbar, dictating how your document is displayed. The Preview tab simulates a standard web browser, though ActiveScripts won't execute. To build the page, use the Normal tab, which keeps invisible structural elements like table outlines visible for manipulation. The HTML tags view acts as a middle ground. It displays your visual layout, but overlays yellow markers to show exactly where the underlying code tags begin and end. For deeper control, the Page pane tabs on the bottom left edge let you switch the workspace between Visual Design View, Split View, or pure HTML source code. By utilizing these viewing modes, you can drag and drop an element on the visual canvas, then flip to the Source tab to see the exact code the IDE generated for you. Now that the workspace is set, the first step in building a form is to generate a fresh canvas. You do this by opening the File menu and clicking New to bring up the Document dialog box. Inside this dialog box, you need to verify 2 settings. Select the radio button for a blank document and make sure the Create N dropdown is set to New tab. Before you can start adding text boxes or checkboxes, you have to establish a foundational container on the page to hold them. Access the empty form properties by clicking Insert, Form, then Define Form. Here, assign a simple identifier by typing Form1 into the form name field. Next, tell the form where to send submitted data by typing form1.html into the action URL box. Finally, set the Method dropdown to Post to transmit user data securely. Once you confirm those properties, the dialog box closes, and a light blue dotted outline will appear on your previously blank canvas. This dotted line is the boundary of your form. The web server will only process interactive elements, like a Submit button, if they are placed strictly inside this defined area. Seeing that blue dotted box tells you your form container is successfully initialized and ready to work. Now that the zone is established, the next phase is to populate it by clicking and dragging functional text fields, radio buttons, and submit commands directly into the box. By learning this interface and setting up the proper container, you bypass the need to write lines of dense HTML, replacing manual coding with an efficient visual workflow. Logging into an account or sending a message online relies on a hidden architectural framework called an HTML form. HTML stands for Hypertext Markup Language, the standard system of tags used to structure web pages. Historically, engineering these interactive fields required a developer to memorize and manually type out lines of complex syntax. Enter KompoZer. It provides a mechanical solution that translates your visual layout choices into that raw code in real time. In this lesson, we will engineer a functional interface containing a name field, an email field, and a submit button using exclusively visual tools. Understanding this visual approach allows you to build complex data collection systems without needing to be an expert in back-end syntax. Let's prepare the workspace. Open a blank page and press the Enter key a few times to give yourself some physical vertical space. To insert the initial form structure, navigate to the top menu. Click Insert, then Form, and select Define Form. This screenshot shows the result in normal view. A light blue dotted outline now surrounds a section of the page. That perimeter is a hard limit. All data elements must be placed strictly inside this dotted boundary. Otherwise, the form will not function properly. Now we define what information we want. Click Insert, Form, and select Define Label. Place your cursor inside the dotted boundary and type the word Name. Looking at the bottom image, you can see the name text successfully embedded within our designated workspace. Click anywhere outside that label field to lock its state. Then repeat those exact steps to create a second label for Email right below it. These labels create a human-readable map of the interface. However, they are static text and do not yet possess any data collection capabilities. To actually capture information, we need to pair those static labels with interactive input fields. Place your cursor next to the name label. Click Insert, Form, and select Form field to open the Properties dialog box. Here you configure two distinct text variables. The field name acts as a hidden tag for the system's memory. The initial value is a visible hint displayed to the user. This dialog box shows the correct configuration. We assign Name as the field name, and we intentionally leave the initial value box empty so the user starts with a blank slate. Next, insert another form field next to the email label. This time, type an example address into the initial value box to provide the user with a formatting example. Looking at this workspace view, we see the immediate front-end result. The email input box renders with our pre-filled formatting hint directly inside of it. Properly configured input parameters act as the bridge between human comprehension and the hidden system architecture. Captured data remains useless without a trigger mechanism to send it onward. We need to add a Submit button. Open the Form Field dialog once more. From the drop-down menu, select Submit button and type the word Submit into both the field name and field value boxes. This Properties box displays the exact configuration. Entering Submit as the field value ensures the button displays that specific text to the user. Let's check our work. Switch your environment from the normal editing layout to the preview mode using the tab at the bottom. In this image, we see the finalized, clean layout, exactly as the end user will experience it, stripped of all dotted editing boundaries. To see what the software built in the background, navigate over to the Source tab. The bottom window reveals a dense block of generated HTML. You can identify specific tags like Form, Input, and Label that correspond directly to our layout choices. The visual interface successfully acted as a real-time translator. It engineered perfectly valid machine logic without requiring us to write a single line of code. You have successfully engineered a complete data-ready web module. Placing 3 visual form elements on a page takes seconds, yet it reliably maps to dozens of lines of precise syntax. Your front-end interface is now ready. The subsequent step is to connect this form to a back-end database. A back-end database is the server-side storage system that will actually receive and process the data you collect. Now it's time to experiment. Try opening the form field properties again and configure alternate variables, like a secure password field or a series of checkboxes. Mastering these structural basics establishes a solid foundation. Understanding how visual inputs map to hidden code prepares you to engineer complex, interactive software environments. Every time you sign up for a service online, your raw keystrokes are securely packaged and transmitted directly to a central database. We are going to build one of these intake mechanisms today. Instead of writing the raw code by hand, we will use a visual editor to arrange the logic. Our specific objective for this module is to construct a strictly formatted functional registration form from a completely blank canvas. This completed interface is exactly what we are aiming for. This workspace shows our target layout, with properly aligned text fields for open-ended data and distinct radio buttons for categorized choices. Mastering this front-end visual layout is a mandatory requirement. If we don't build and name these collection points precisely, the back-end database will have no way to understand the information we send it. Step 1 is establishing our file's overarching identity before we generate any of the structural elements. Looking at the page title dialog box here, we enter the text Example 1, which displays in the user's browser tab and bookmarks. Moving down to the Save As dialog, you must manually type .html so the operating system recognizes the document as a web page. Next, we need to create the form container. Think of this as an invisible envelope on the page that groups independent user inputs together so they can be transmitted simultaneously. Go to the top menu, click Insert, navigate to Form, and select Define Form. This brings up the Form Properties dialog. We assign the form a name, Form 2, and set the transmission method to POST. POST is a standard protocol used to send sensitive data to a server securely, keeping it hidden during transit. Once you hit OK, a light blue dotted boundary will appear on your blank canvas. That boundary acts as our data payload. Any text fields or buttons we place inside that specific perimeter will be packaged into a single, continuous data stream when the user clicks Submit. We will give our container some structure by creating a central heading that reads Registration Form at the top of the page. Now we construct the input points. This requires pairing static text labels, which tell the user what to type, with interactive blank fields where they actually type it. Here in the Form Field Properties dialog, we set the back-end variable name. Notice that first name is typed as a single, unbroken word. Including spaces in a variable name is a common error that will corrupt data when the server processes it. By repeating this exact sequence, we establish the middle name and last name inputs. The main workspace now shows a clean, stacked list of 3 distinct text fields. Because we gave each field a precise spaceless variable name, the backend database now has exact coordinates to pull the user's raw text from and automatically sort it into the correct columns. Open text boxes work perfectly for names, but for specific categories, we need to limit the user's options. We enforce this limitation using a radio button, an interface element designed to force a single, mutually exclusive choice from a list. We open the Form Field Properties dialog, setting the field type to radio button. In field settings, the group name is gender, defining the category. The field value is male, which is the exact data sent to the server if this button is clicked. Check the box for Initially Selected to ensure the form has a default answer ready the moment the page loads. When creating the second categorical option, in this case female, you must assign it the exact same group name as the first button. That perfectly matching group name is the invisible mechanical link. It forces the first button to toggle off the instant the second is clicked, mathematically preventing the user from submitting contradictory data. Looking at the completed workspace, we can review our structure. The blue boundary is intact, the text fields are correctly labeled, and the mutually exclusive radio buttons are in place. To verify the structural integrity of the code, open the file in a standard web browser and physically click the radio buttons to ensure they toggle correctly. Once verified, commit the final structure to your hard drive to preserve the underlying source code. By arranging these core layout elements, we have successfully built a reliable data gathering tool. With our single choice logic confirmed, we are ready to tackle multi-selection variables like checkboxes in the next lesson.
Welcome back! So far, we've used standard text boxes to collect simple data, like names. But if we need to gather a paragraph of text or let someone choose multiple hobbies, a simple text box falls short. Take a look at this completed registration form as it appears in a web browser. Today, our goal is to build this exact layout from scratch. To build it, we need to master a few specific input tools: checkboxes for multiple selections, wide text areas for long answers, drop-down menus to save space, and the buttons that make the whole thing run. If we force users to type every answer into a blank text line, they might misspell a city name or format their address in a way our system can't read. It creates messy data for us and extra work for them. Matching the interactive tool to the specific type of question ensures the data we collect is accurate, standardized, and ready for automated processing. Step 1 is capturing data where a user might have more than one correct answer. For our Hobbies section, we want a Select All That Apply approach. The checkbox is the ideal tool for this. Inside KompoZer, go up to your main menu, select Form, and then Form Field. When the Properties dialog box opens, click the drop-down and select Checkbox. In the Form Field properties, notice the field name. To group checkboxes together, they must share the exact same field name, like Hobby. Below, we set the field value to Singing to identify the clicked box, and optionally check Initially Checked. Using that identical field name for singing, dancing, and reading creates an invisible thread. It ties those separate boxes together into a single cohesive piece of data upon submission. Next, we tackle the Address field. An address usually requires multiple lines for the street, apartment number, and zip code. A standard single-line text input will truncate their view and immediately frustrate any user trying to check their own work. To fix this, we use the Text Area element. Go back to your Form menu and click Text Area to open its specific properties window. Look at this Text Area Properties dialog. Unlike images that use pixels, text areas are sized by character space. You control the height using rows and the width using columns. Here, we've set the rows to 5 and the columns to 70. By explicitly typing in those row and column numbers, we guarantee the form layout remains readable and give the user plenty of physical screen space to type out a complex address. We also need to ask the user for their city. If we list every possible city as a radio button, the form will stretch on forever. A selection list or drop-down menu offers dozens of choices without consuming massive amounts of screen space. To build one, navigate to your form menu again and click Selection List. In the Selection List properties, our first step is assigning a master identity by typing city into the list name box. Next, type your first choice, like Ahmedabad, into the option text field below. The system automatically copies it to the value field. Stop right here. Do not click OK yet. If you close the window now, your option won't save. You must manually lock in every single item by clicking the Add Option button on the right side of the screen. Repeating that process, typing a city and clicking Add Option, creates a fully populated list. Notice the check mark next to Rajkot. Selecting an item and clicking Initially Selected makes it the default city when the form loads. These lists enforce strict data hygiene. By restricting inputs to a predefined set of choices, we eliminate manual typos and guarantee every submission follows our required format. We now have all our input fields. However, a form full of data is entirely useless if the end user has no way to send it to us. To finish the layout, we return to the Form Field menu to select a Submit button to send the data and a Reset button to clear the fields. Both buttons rest at the bottom of our completed normal view layout. These action buttons provide the necessary logic to process the user's inputs, moving the project from a visual layout to a live, interactive data tool. Now that the build is done, it's time to test it. Start by saving your current workspace as an HTML file. Before leaving KompoZer, look down at the bottom of your screen. This image shows the Preview tab. Clicking it strips away the editing tools and gives you a quick check of your structural layout. But the Preview tab doesn't run the actual interactive code. For a true functional test, we need to open that saved HTML file inside a real web browser, like Mozilla Firefox or Google Chrome. Once it's open, you can see our final rendered browser view. Now interact with it. Click multiple hobby checkboxes, type a few lines into the address text area, and click the City drop-down menu. If everything behaves as expected, your code is solid. Successfully interacting with the form in a live browser confirms that KompoZer has accurately translated your visual design into functional web code. We have the mechanics down. In our next lesson, we will apply background colors and aesthetic design to complete the project. Web forms are the primary way we collect information online, but standard HTML forms default to a stark, unengaging white background. This sterile layout often fails to capture or hold a user's attention. To fix this, we will use the KompoZer IDE to transform a basic interface into a customized user experience. An IDE, or Integrated Development Environment, provides the comprehensive digital tools necessary to build and style web pages within a single application. To follow this process, you need two things ready: KompoZer installed on your system and a basic, unformatted form already open in your workspace. Learning to manage these aesthetic controls is a necessary step in user interface design. By adjusting the visual environment, you can more effectively direct a user's focus. With your form open in KompoZer, go to the top menu and select the Page Colors and Background dialog box. This chart shows the default configuration. The software uses the reader's local settings, preventing custom design choices. To override this, select the Use Custom Colors radio button. This enables the specific color options below. With these options now active, click the color swatch next to the Background label to open the secondary color selection window. In the Block Background Color window, pick a shade or use the predefined grid, then click OK. Click OK on the primary dialog box to apply the new hexadecimal value, a standard 6-digit code defining specific web colors. This two-step confirmation process is a common feature in development software. It ensures that style changes are intentionally applied to the document variables. Now we must verify the visual change. Remember that the raw design workspace in an editor does not always accurately represent the final output a user sees in their browser. To view a local render, switch from Design mode to Preview mode using the tabs at the bottom of the interface. This view shows the rendered form. The registration form is now displayed with the light blue background we selected, confirming that the settings were applied correctly. While the Preview mode is a useful check, the final step is to open your HTML file in a web browser, confirming the code interprets correctly in standard web software. Establishing a habit of checking your work across these different environments, from the editor to the browser, is a key part of the development workflow. Having addressed the visual layer, we must now look at the technical definitions that govern how these forms function on the web. An HTML form is a container designed to collect various types of user input, such as text or selections, so they can be transmitted to a server for processing. We are using KompoZer because it is a WYSIWYG editor. This stands for What You See is What You Get, meaning the graphical interface allows you to design the page without manually writing every line of HTML code. Every form uses a form tag with two essential attributes. The action attribute identifies the destination where the data is sent, while the method attribute determines how that data is transported. The primary values for the method attribute are get and post. Get sends limited data by attaching it to the URL. In contrast, post packages data as a separate block within the HTTP transaction, necessary for larger datasets. Understanding these routing mechanisms ensures a form is not just a visual layout, but a functional tool moving data across a network accurately. Reviewing our progress, we have successfully replaced a default blank background with a custom color that fits our specific design requirements. This laboratory exercise section provides an opportunity to apply these skills. Practical application is the best way to reinforce these technical concepts. Your assignment is to complete the second task. Create a new feedback form for school guests and apply a custom background color to it. Try to navigate the menus and apply the settings without returning to the previous steps of this guide. Building these forms independently will help you become comfortable with the KompoZer interface. This experience provides the foundation for more complex web development projects in the future.